Okay, we will work through the quiz 4 for statics, MENG1230. So here's the quiz on our paper here. Let's see what we've got. So when we come down, we're looking for the tension. So let's see, we've got all right, so here we go. We're looking for the tension, so it means that's a force. So we'll have units of newtons. We're looking for each chord. I should have been maybe more specific. I'm looking for AC, BC, CD, and DE. DF I know from the weight. And then I need free body diagrams, FBDs, for each point here. So as we look at our sketch, we also know that this the mass of the lamp is 20 kilograms. So one thing we know is if this is in equilibrium, both point C and point D are in equilibrium, right? So the whole rope lamp tension assembly is not moving, so that means both points D and C are not moving. So what's our approach? Approach 1, step 1, draw free body diagrams for each point. For D and C. 2, solve point D. So we'll use 2 steps there. A, sum the forces in Y set equal to 0. B, sum the forces in X set equal to 0. Then we will move on. Step 3, we'll solve for point C. Not C, not 3, but C. There we go. All right, so that's our approach. Let's scroll down here a little bit, and we'll start a free body diagram. So around point D, we have our weight. This is DE here, and that is 30 degrees above the horizontal. And then we have a force going this way, and that is CD. So we'll use that one there, and then also at the same time here I'm going to write around point C, free body diagram. So we're going to have this force coming up here, and that's 3, 4, 5 triangle there. We have force CD going that direction. We have BC, and that one here is 45 degrees there. So there's our 2 free body diagrams. We'll be finished with step 1. All right, so we'll solve now step for point D. So in point D, here's our free body diagram over here. We know some of the forces in the Y direction needs to add up to 0. So what do we have there? So we have 0 equals negative 40 kilograms. So to get that into newtons, we're going to multiply by 9.81 meters per second squared plus dE sine 30. Right, so the vertical component here is going to be sine of 30 times the horizontal, or the hypotenuse, the dE magnitude. So we can do this math, pull that force over to the left-hand side, and if I do that, I find that force is 196.2 newtons equals dE sine 30. And if you may recall, sine 30 is 1/2. So dE equals 2 times 196.2 newtons. So it goes to 392.4 newtons. And for significant figures then, dE 392. So there's one of our tensions we need to find. Now we'll add up in, let's see, we'll come down a bit more. We'll get, oh, I'm going to stick up there, huh? Okay. So we come down. Now we're going to do the x direction, still on point. Oh, goodness gracious. There we go. My pen turned back on here. So in the x direction, sum of the forces in x have to equal 0. So we have 0 equals dE cosine 30 degrees. That was going up and to the right, if you recall. And to the left, so negative sign will be CD, and that was horizontal. So CD equals dE cosine 30 degrees. CD equals 392.4 newtons, and cosine of 30 is, oh, why did I turn my pen off? Is 0.866. And then CD equals 92.4. So CD equals 339.8 newtons, or the three significant figures, 340 newtons. All right, so that's around point D. We're all finished with that. So we'll use this CD in our equations of equilibrium around BC, around C, to solve here. So we're going to take point C, sum of the forces in X is what we'll start with, since we know this force here. It's going to be 0. So 0 is going to be 339.8 newtons. That's our CD minus AC. And we can just use our triangle here. We don't need to figure out the angle before you can use sine or cosine. So it's going to be 3 over 5. And then we're going to have minus BC times cosine of 45. So we can pull those AC, BC over to the same side. AC, or 3/5 AC, plus BC cosine 45 equals 339.8 newtons. So we can find that in terms of AC or BD. I'm going to leave that at that point, leave a little space here, but that's helpful. So then I'll do round Y. So the sum of the forces in the Y direction can equal 0. So we have AC has a vertical component going up, it's going to be a positive. BC is going down generally, so that's going to be a negative. So we're going to have 0 equals 4/5 AC, right? There's it right on our triangle. There's our 4, there's our 5. So that's 4/5 AC is the positive Y component of that. And then we're going to have negative BC sine of 45. So BC sine of 45 BC sine 45 equals 4/5 AC. So we'll just solve for AC in terms of BC here. So AC equals 5/4 sine 45 BC. And I'll take that and fill it in here. So we're going to have 3/5 times 5/4 sine 45 BC plus BC cosine 45 equals 339.8 newtons. When I do that math, BC equals, I get 274.6 newtons, which goes to three significant figures, 275 newtons. And now I'll take that back down here. So AC equals 5/4 sine 45 times 274.6 newtons. And when I do that math, let me scroll down to give myself a little room to write that. AC then equals 242.7 newtons to three significant figures. It's 243 newtons. So we get plus 2 points for this answer, plus 2 points for this answer, plus 2 points there, plus 2 points there. So that's 8. And if we scroll up here, we're going to get a point for each free body diagram. So there's 1 there, plus 1 here. So that gets us our 10 points. So the key there again is to break the whole problem down into 2 points. In this case, where we know we have equilibrium, that gives us one unknown here, one unknown here. We know this force, so we can do our 2 equations of equilibrium in x and y, solve for those 2. Then we move over to point C. We have these 2 as unknown, AC and BC. We know CD at that point. We have 2 unknowns, 2 equations, equilibrium in x and y, and we can solve that.